Hi there. Today we are going to discuss the command design pattern. Just like the word command depicts, you can think of it as a command emanating from a particular person. If you think about a military organization or any hierarchical organization, a command is given out by the boss and an action will be taken to fulfill that particular command by somebody else. You can think of this command as a request from somebody. For example, we all go to different offices to fulfill a request. So we fill out a form, and then that means that we give a request and an action will be taken by somebody else on that particular request so that something gets fulfilled for us. So you can think in that terms too. Here, what we are going to do through code is we are thinking of a scenario of a restaurant or a diner where the customer walks in and then he gives out a command. Here also, you can think of the customer giving a request for some food items. So, and of course, who is going to cook the food? So, the request is coming from the customer. And then of course the waiter will take that particular request, hand it over to the kitchen, and then the kitchen staff, the cook, the chef, whatever, will fulfill or take action on that particular request. This is what the command pattern is all about. So without much ado, let us see the initial interface or the type of this, how the command looks, and then we will take it from there. You can see here that we have a small interface called command, and that has just one method called execute. And now we are going to have an implementation of this particular command interface. Please remember the discussion that a command is going to be generated by somebody and an action has to be taken by somebody else. Because we are depicting a restaurant or a diner here, we are thinking in terms of a command emanating from a customer, and then an action is going to be taken by a cook. So there has to be a cook interface. So let us implement or design the cook interface next. The cook interface is also very simple. It has just one method, the prepare order. Now it is time to have a solid implementation of the command interface. Because we are depicting the workings of a restaurant, the command that we are going to show here is an order that is received from the customer. Or think like the waiter has taken the order from the customer. So let us have an implementation of the command interface, and I'm going to give the name of one of the commands as the order slip. So it is going to implement the command interface like so, which will have just one method, the execute method. As we have already discussed, when the command is generated, who is going to generate the command? The customer or the waitress will receive the command. And who should execute the command? The cook in the restaurant. So that's the pattern. So somebody else will create an object and the execution or the request based on that particular command will be done by somebody else. So in this case, that somebody else is going to be our cook interface. So let us encapsulate the cook inside this order slip implementation. And of course, we want the cook to be provided when an order slip is generated. So the best thing to do is to create a constructor with the cook as the argument. So this is a command, and that means an instance of the order slip will be created. When the instance is created, a cook instance is also going to be generated who should take action on that particular order. So when should the action takes place? When the execute method gets called of the command interface. When the execute method of the command interface gets called, who should take action? The cook should take action. So here he will prepare the order. The command interface is that simple. But even if it is that simple, it leads to innumerable possibilities like message queuing, logging, and all the stuff. So what we are going to do, we have completed the command interface, but we have only the cook interface. We don't have any implementations. So let us have some cook implementations, maybe a vegetarian cook or a pasta cook based on the kind of restaurant. So we will keep our discussion simple and have two cook implementations next. We have created two cook implementations. One is the veg cook that prepares vegetable dishes or vegetarian dishes, and the pasta cook that cooks pasta. Now it is time to create the orders and see the whole thing works. To see the thing works, what I'm thinking of is that we are going to create a chef that delegates the responsibility. That means the chef will receive the order slip handed over by the waiter or the waitress, and then once the order slip has been received, the chef will hand it over to the appropriate cook to prepare the dish. That's the scenario that we are trying to. So we are going to create a chef class that will have the order slip, and let us see the code, how it is done. The chef class is really simple. The chef class contains an order slip encapsulated. It has one method called the set order. Based on the type of string, the value of the string that is passed into it, it will create an appropriate order. The order slip, if you know, it is the command. So if it is a vegetarian order, and an appropriate order slip will be created with an appropriate cook assigned to take care of that particular order. The same thing goes for the pasta too. And the next method, the order up method. So that is where it is the completion of the chef. So when that particular order up gets called, then the execute method of the command get executed. So you can see here the order slip, which is the command whose execute method will get called. So what happens when the execute method gets called? The cook, which is encapsulated inside that order slip, will take care of preparing that particular food. So this is the command pattern. So to complete our discussion, let us create a main class with the main method. Let us create a new chef like so. Let's create a chef. So what we are going to do, we are going to call chef dot set the order. We are going to create a vegetarian order, and then of course has been received. We will call the order up method. We will keep the code simple. So you can do the same thing with the pasta too. So you can see here, I'm just keeping our discussion simple. You can definitely introduce a customer, then customer receiving the order, or maybe the waiter or the waitress taking up the order and then handing over to the chef, and then chef delegating the responsibility to the corresponding cook and all the stuff. Here, the thing here is that the whoever is giving the command doesn't need to know what is happening behind the scenes or who is taking that particular action. So the chef will set this particular order. The chef doesn't necessarily need to know who is actually taking action on that particular order, even though in code it looks like, of course, the order slip is created inside the method, but of course, we are not complicating the things. Here we are creating a cook, different instances of the cook. It can be another factory method from where the cooks have already created, or and we are getting that particular cook dynamically, something like that. Again, we are not complicating things. So here the command is generated somewhere and it is getting executed somewhere else. So let us run the application and see whether whatever that we just discussed is working properly or not. So you can see that the order was given for a vegetable dish, and then of course you can see the preparing veg dish is coming from the cook interface or the implementation of the veg cook where the preparing veg dish comes. This is one of the simplest implementation or the simplest exploration of the command. But how can we complicate this further? We will show just one more example where some threads, we are going to talk about a message queue system where a lot of messages will get generated. Again, nothing is different from what we just discussed. We will have the same command interface. We are going to create a new class called message. That message is going to be generated randomly by some threads, and then some other thread is going to receive this particular message and take some action. So that will complete our discussion on the command pattern. Let me create a package first. I will give the name of the package as log. Inside that, I'm going to create a command, and the name of the command is message. Because it is going to be command, this will implement the command interface and thereby implement the execute method. So somebody is going to send a message, that's the command or the request, and somebody should take care of that particular request. And who is going to take care of that particular request? Here, what we are assuming is that this message will be consumed by a logging system. If you look at the Gradle build that I have used here, I am using the Lombok library. If you come down, you can see I am using a plugin for the Lombok library. Again, this is not the time to discuss Lombok, and I am using the logback as the logger for logging the requests. So we have created a command called the message. This message is going to be received or to be executed by a logger. So what I'm going to do, I am going to use the annotation, the SLF4J, that actually introduces a logger as an encapsulation. So if I put my mouse on top of the SLF4J annotation, you can see this causes the Lombok library to generate a logger field. So you can think of me typing this particular private static final log. This logger is going to be encapsulated inside that particular class. So in this case, the message class contains a logger encapsulated. That's the guy who is going to receive this particular message and execute it. For example, when a message is generated, and what happens, and then when it is time to execute this particular message, it will be the log. So what I'm going to do, I'm going to put this log info and then message received. I can do that, or better, I will have another string encapsulated MSG, and then I will create a constructor with that particular message like so, and then I can just have this MSG like so. So what we just did is to create a command, and then I am encapsulating this particular command with a logger. Why? Because we already have discussed what is the command pattern all about. Somebody is going to create a command, and when it is time to execute that particular command, it will be taken, the actual execution is done by somebody else. So in this case, this is the message, this particular message carries the MSG, and then when it is time to execute that particular command, it will be the logger that will take the actual action of logging that particular command. So the logger can log this particular message to the command prompt, or he can send streaming to some other location like Kafka or whatever. That is not our discussion. So we have created the message. The next part that we are going to do, we are going to create, this needs to be consumed. So we are going to create a queue system where we are going to send a queue of messages, and we will use a thread to create some messages and send it to the queue, and then another thread will execute these messages at the appropriate time. That's what we are trying to depict here. So in order to do that, let us complete the code of that particular message queue system. As a simple explanation of the code that we have just written, I have created a message queue class, which consists of a single property which is of type the concurrent linked deck, which is an implementation of the queue, and this is concurrent, meaning multiple threads can easily add or remove messages to and from this particular queue. So the point of discussion is this particular dispatch method. As we have already told, multiple threads will be generating messages, and using this particular message queue instance will call the dispatch method and add those messages. So when the messages are dispatched, it will be added to the concurrent queue. And when it is time to execute or do some processing on the elements of the queue, what are the elements in the queue? The message is the element, which is the command. We call the execute method. So you can see here, this is the execute method. When the execute method, so you can see the pop message is called first. The pop message will retrieve the message as well as remove that particular element from the queue, and then we call the execute method. The execute is the command's interface method function. So when it gets called, how did we create the message? It is encapsulated with a logging system. So the logger will execute whatever is the action that needs to be taken. This is what this message queue is all about. The next thing that we are going to do, we are going to create the main class. We will generate some messages and see how the thing works. I'm going to create a main with the main method. First thing, we are going to create a message queue instance. And next we are going to do, I am going to use an int stream, and I just want to create a loop. That's all I am going to do. So, and for each of, so instead of using the for loop and all the stuff, I am using the int stream. So each of the loop, each of this particular loop, what I am going to do, I am going to create a thread which will be having a runnable. So what I'm going to do, I'm going to log. So for log to appear, I'm going to use the same old SLF4J annotation. So first I'm going to log dot info generating message, and then I will provide what exactly is the message, and then I'm going to use this particular queue variable and call the dispatch message, passing in the command which is the message. So I will just give message, then plus I, like so, and then I will start. So what I have just done, created an instance of the message queue. Then I am looping, giving 10 loops. For each of this loop, I am just creating some threads, one thread for each loop. And then of course, and what does that each thread do? It logs that particular message. So this log, why I am giving this particular log, we can see which thread is actually executing this particular piece of code. So that particular thread will be executing. So the intention here is that multiple threads from different places will be generating different commands. What you can do here outside, I am going to use another log dot info, here also generating message, and of course here the log. So which thread will be executing this particular log? This particular thread. And who will be executing this statement? The main thread, because we are in the main method. So here also we can use the queue and then dispatch a message. So let us give a message, just some custom message will do. So multiple threads, some 10 threads we have created here. We are using an existing thread, that is the main thread, that will be executing. So multiple threads will be using the queue instance variable to dispatch commands. And then because we don't want the main thread to exit, I am going to make this sleep for maybe some 1000 milliseconds, because it will throw, I think, an interrupted exception. Let us put inside a try catch block like so. And after that, I am again going to create another thread which we are going to pass a runnable, and now we are going to use the run method and then start that particular thread. So again, a simple explanation, multiple threads will be dispatching messages to this particular queue. So here different threads, and again the main thread is also dispatching messages to the queue. Once it is done, just to make sure that the whole thread have dispatched their messages. So in order to avoid the main thread exiting from this, I am sleeping the main thread for a little while and then again creating another thread and then calling the run method. The run method is where the actual processing happens. So when the run method, again the run is done by another thread. So you can see here the messages will be put inside this deck by multiple threads, and then that means the dispatch method will be called by multiple threads. The run method is going to be called by some other thread. So or a single thread, in this case one thread, and that will be executing this particular. So multiple messages. Again, just a simple example of how this particular command pattern can be used. Let us see the execution of this application before we wind up the discussion. So if I expand this, you can see from the message, from the log, that you can see these are the logs that is coming from. You can see the different threads is generating these messages, and these messages are generated because of this line of statement. And of course you can see there is a custom message, and this custom message log generating message generating. Now this is the dispatch. This is the message that is getting processed, but there has to be, you see here, there is the main method. This is the main thread that is generating, that is executing this particular. So that's why I stopped this particular main thread for a while. You can see even before these threads started executing or generating these messages, the main thread already reached here and executed this particular message. So generating message, and you can see here this thread 10 is the last thread, this guy that we created. This is actually processing, calling the run method, and of course you can see the custom message which was generated by the main thread reached it first. So of course it was processed first, and of course you can see this only is one single thread is running that particular run method, and this is executing. So who is executing? The logger is executing those messages. Again, just a simple explanation of the command. So before we wind up the discussion, what exactly is the command? A command is an implementation of one interface called the command, which will be encapsulated by who is going to take action on that particular command. In this case, in the case of a message, it was the logger that was encapsulated inside that particular command that took action. In the case of the cook, in the order slip case, the order slip was the command. And who should be taking action on that particular order slip? The cook, and the cook is encapsulated inside this particular command. This is the command pattern for you.